Good morning, everyone, and welcome to the day 3, last day of the International Conference Earth Sense 2025. The conference is technically sponsored by IEEE GRSS and financially supported by GRSS IDEA, GRSS YP, GRSS TEIAB, IEEE Dataport, TCS Research, Urban Kitchen, with coordinators as our media partner. A heartfelt thanks to all the sponsors for making this event possible. Now we will begin today with a YP breakfast technical talk by Ms. Raisha Tatoli. Ms. Raisha Tatoli brings strong expertise in the field of automotive systems spanning both AutoSAR and non-AutoSAR based platforms. She has proven background in embedded C development, specializing in critical areas such as bootloader development, MCAL, and complex device driver, CDD drivers. With her deep technical knowledge and practical experience, Ms. Raisha Tatoli has been contributing to advancements in embedded systems and automotive software development, shaping innovations that drive the industry forward. We are glad to have you here. Now I invite Ms. Raisha Tatoli onto the stage.
Hello, everyone. I was expecting more participants, but uh, anyway, we'll start. So this is the title of my presentation. I will be talking more on, I don't know what background you all are and even what is the, in which domain you are research going on, but I will talk a little bit more on urban issues or urban challenges in India. And you can think about your research perspective and how the methodology or the research approach is useful for your research. Yeah. So yeah, this is the title, Geospatial Insights into Urban Expansion and Mobility Challenges. Yeah, next slide. Yeah. Before jumping into the research or the main technical session, I want to introduce by myself because many of them may not familiar about me, right? I am a postdoctoral fellow with the Bangalore Science and Technology, that is a part of Indian Institute of Science in Bangalore. And currently, I serve with different other labs as like the researcher position with other labs with the Spatial Computing Laboratory or Web Science Lab at IIITB. And I am a visiting senior research associate with the University of Johannesburg, South Africa, because this is a kind of a research collaboration we do. Um, Apart from all my research or academics, I work as a volunteer for GRSS. I served as a regional chapter coordinator for entire nation, and currently I am a chapter committee member. Yeah. And I am a mother of 2 kids, and Dev and Ved. I should highlight that as well because as a working woman, Indian woman, like both the way we should be success, right? Like family support, family side, or even the research, the profile. And this is my research interest. GIS and remote sensing is my key area and applications in urban science. And more into because as I'm from a civil engineer background, my master's was in geoinformatics. Then I was trying to look into how these technologies can be linked with my background. So civil engineering has a multiple disciplinary kind of a transportation engineering, environmental engineering, water resource engineering, multiple, right? So I was like, when I start my research, I was thinking how I can use these technologies in the real world problems. So yeah, this is my education background, my experience, and my few of my key research thesis. Like a PhD work is more on urban science, and after my PhD, I started my work into the extended version of my PhD is more into urban climate, urban weather, and now currently working more on mobility issues in Bangalore. Yeah, that is my bio, and now I'll talk a little bit more about my institutions or which organization I am from. I am from BEST, that is Bengaluru Science and Technology, that is what BE stands for. And this is a part of Indian Institute of Science, and yeah, I'll talk more about. This is initiated in 1999 with the principal scientific advisors. They actually, what we do a lot of we provide pragmatic and some kind of solutions to their prime ministers and of cabinet regarding the science and technology challenges in India. So initially in 1999, Dr. APJ Abdul Kalam sir was a principal scientific advisor, and currently Professor Ajay Kumar Sood is serving as a PSA position. And yeah, we have a multiple clusters in India. We have around, I'll show this here. We have 8 clusters currently. I am a part of Bangalore, but you can see in Hyderabad also we have a cluster. Those who are from Hyderabad, you can see what kind of activities these Hyderabad cluster is doing. You can see Delhi, Dropar, Jodhpur, Bhubaneswar, Visakhapatnam, and Pune. These are the other clusters in India. So this is what, like, we are looking into the national and global challenges and how the science and technologies can provide solution for these kind of challenges. And it's kind of a shared ecosystem. If Bangalore have some problem, if it's kind of like if we are able to provide a solution for one cluster, we can scale up into the other cities as well. And I was talking about the shared ecosystem, right? Because we work with a multiple institutions, because this is the hexahelical model here. So we with a multiple academia, we work with industrial startups and government, finance, or even the society, like all other NGOs as well. And currently, this Bangalore cluster has launched in 2022, November 15th. Currently, we have a main 3 themes. The first themes comes in a health and wellness. All the 8 cluster, what I was talking about, they are interested in multiple themes. Currently, we work with health and wellness and urban life and futuristic solution. Under these themes, we have 8 entities. In that 8 entities, few of the entities are overlaying with some of the themes. You can see I am part of urban life, and mobility is one of the main key entity within this theme. And One Health, digital health, precision agriculture. Yesterday, there was a talk from Urban Kisan, right? Urban, like the agriculture related or the precision farming. All this comes as a one entity within our cluster. Yeah. So there were a brainstorm session in 2023 regarding the mobility, because those who are, even if you know about Bangalore, we know that Bangalore is infamous for traffic congestions, right? The mobility is the biggest issue in Bangalore, and we had a discussion with many experts and NGOs, many stakeholders, those who are in the similar field. So we have had a detailed discussion, like what is the problem, and what are the things we can do, and how the technologies can be useful for creating some of the providing some of the solution for these kind of challenges. So we have 2 main white papers, or even 2 main research is parallelly going on with the BEST cluster. One is mega regional mobility plan. So we are trying to make the multi-modal mobility solutions and plan for a mega regional area in entire South India. And even another project led by Dr. Ashish Verma from IIC is like, because of the new metro or new yellow line metro, how it is affecting the public health. So that is another project with a BEST. Apart from all these research activities and collaborations, we do a lot of capacity buildings as well. Like we go to the colleges, some of the government colleges, industries, and we do a capacity building. Then this is the one I want to highlight here because recently we have launched one scholarship for women STEM, with those who are working in STEM, especially for biotechnology, microbiology. This is open. Those who are from Karnataka, if your friends are from Karnataka, you can just share this information to them. The PG students, the UG students, or those who are doing some, they are called for a scholarship for these kind of it. You can look into this activities, and now we yeah, this is those who are interested to know about cluster, what is like Hyderabad cluster, Bangalore cluster, whatever it is, you can see the newsletters or even their website. This is the some of the social media activities within our cluster. Then we work with the multiple stakeholders. This is what brief about myself and even my company. Now we'll jump into our research topic. So the introduction and background regarding the urban challenges. I hope as this is a part of GRSS, many of them may aware about GIS, remote sensing, all these technical stuffs, right? So in my case or in my session, I will talk more on how this is useful for urban challenges. Like there are multiple challenges, but I will share some of the insights from my previous research experiences. Yeah. So simple questions. Where do we live? We all are in cities, right? Many of them, like we love to move to cities because the city is welcoming us with opportunities or even job opportunities, education. So there are a lot of pull factors to the cities, and you can see some of the statistics here. 1971, you can see the region, that bluish color, right? Most of the people or most of the citizens were living in the regional area, but now the conditions has changed. In 2050, it is going to be, you can see the red color, right? Here in red color. Yeah. Sorry. Yeah. You can see after 2016, more than 50% of citizens are living in cities. Okay. So in 1800s, it was just 3%. The entire population, it was just 3% representation of a urban population. But in 2050, it is going to be 68 to 70. I'm talking about the global statistics. It is going to be 70% people will be living in urban area or cities. Yeah. When it comes to Indian statistics, 2024, the population, urban population, it is 37%, and now in 20, like the after some years, 2050, it is going to be 53%. So you should see the alarming factor here. So 37 to 53 is not, even though it looks like it's not a big number, but as compared to the Indian population, it is going to be a big number. Yeah. So once the population is there, you can see some of the major cities, major metropolitan cities in India. Metropolitan in terms, if the population lives, like the number is more than 10 lakhs or 1 million, that we call it as a metropolitan cities. These are the major metropolitan cities in India. I just highlighted Bangalore because my research was focused more on Bangalore. Now the current work is more into the entire cities, but this initially, I started with a Bangalore as a case study. You can see the population number every year. It is going to be around the current population plus 4% of the current population. This is something is we should think about. This is the big news, right? Every time the population is increasing means it's alarming thing. So when you look into the urban system is not a very, it's not a simple thing. It's a very, very complex system. It's not only related to population, it's related to ecosystem, related to urban climate and weather, transport, infrastructure in terms of building or even in this transport road network and all. So this you can see urban system is a very, very complex system with a multiple challenges and multiple subsystems. And the major factor for any kind of urbanization is one thing, that is migration or even the natural increase in population, the normal increase in population. And 77% of the global urban population is expected to be in a developing country. This is, I just highlighted, developing countries like India. most of the urbanization happening in these kind of countries. Yeah. So one way urbanization is good. That is why we are here, right? Because I am from Kerala, is in a small village. We don't have much opportunities for education. I moved to Bangalore for my education. But based on my experience and based on my research, I had opportunities in Bangalore rather than in Kerala. So that is why I settled in Bangalore. Similar way, you also have the similar kind of a stories, right? You moved to Hyderabad for your education, or even that is why the cities are good. I am okay with that. I am happy with the positive response of city or even this kind of urbanization. But think about the negative side. That is the drawback of these kind of urbanization. How this urbanization affecting in air quality or environment challenges, or even resource scarcity, because these many people are coming, so that many natural resources or the space that is not sufficient for us to accommodate all this kind of a growth. Yeah. So as we all are graduated, we know that one way urbanization is good, but how this is affecting the other side, and we should not just understand, we should think about it, and we should start working on it, how our knowledge or how our work can be contributed to the better future. This motivates me to work on kind of how to decide, or how to frame my research objectives based on these challenges. And most of them are behind sustainable planning or sustainable development goals, right? The 11th goal is regarding the city planning and sustainable city or future sustainable cities. This is how I frame my research objectives towards the sustainable planning. Yeah, this is the few insights from my PhD work. The first thing is, if you want to know one city, we should know the history about that city, right? How the city evolved, what was the condition before. Through satellite imagery, through remote sensing, we could track how we can track how the expansion happened. So last 50 years of data can be downloaded. It is freely downloadable from NASA or even USGS website. There's a Landsat series of data. Those who are not from a remote sensing background, you can think about it, how these kind of things you can make utilized for your city. Yeah. So 1973 to 2023, how the city is expanded and which area is this trend, or which direction this kind of expansion is happening. And GIS will help you to visualize which are the hotspots of these cities, and we can identify the pattern, we can visualize it, and we can quantify these patterns. That is the best and beauty of GIS, right? We can visualize, and how much this kind of a quantity you can measure through GIS software. So just listen here, because this is the BBMP area. I'm not sure you are able to see the screen. You're able to see the black boundary here, black here. This is the BBMP area. So this is the part. This is the main core Bangalore area, and my study area I extended from like overall it is something like 4,216 square kilometer as a study area. But administrative boundary within the BBMBA is just 720 square kilometer. Because most of the researchers and experts already overlook this problem of Bangalore. It's expanding. But for my research, I look into some other, like the surrounding regions as well, extended version of the study area. You can see you can see here, those who are from, those who know Kembaguda Airport, that is the international airport in Bangalore, you can see it is very, very far from the center part of the city. If you want to reach to airport, so you should start 2 to 3 hours prior. Yeah, you should consider the traffic. You should understand the which transport mode you are taking care, and how far it is, all this scenario it should keep. If you, because if because my flight was at 7:20, I started, because it's early morning. Yesterday, the story I was like, I started around 4 o'clock. So you should think, if with this Hyderabad, it's just a 30 minutes of drive, right? But Bangalore, the condition is not the same. So this is one. We don't have a proper multimodal transport facilities. Also, we should depend on some of the private vehicles or cab facilities. So that is one thing. And this is because the population of entire Karnataka, or even the different cities in Karnataka, Bangalore's population is very skewed one. The population is much, much higher than any other cities. Even the second largest city in Karnataka is Mysore. Anyone familiar with Mysore? Yeah, Mysore is also does not have a that highest population. It's a kind of it's a skewed population we call. So this is the highest contributor to the Indian GDP, the city. So city has a lot of good things to talk and a lot of challenges as well. So now I will show some of the result, because I'm not talking more on methodological side, but I will show more results to you. So you think about how the satellites or GRSs can do a lot of things within this kind of a research. You see this is a historical satellite image, like converted land use land cover maps, because from satellite imagery, you can prepare land use land cover very easily. So many tools will help you to do that. Initially, you can see, you concentrate on red color here. In 1973, it was just a centered part of the city was very, like the highest building density. But when times goes in 2023, other states also getting involved. Even the Hosur is in a Tamil Nadu, but you can see here, this is a Hosur area. This is also expanding a lot. Urban expansion is happening in this direction, or even north Nelmangala side, or even a lot of changes after the construction of international airport and the surrounding area. And you can quantify how much it is increased from 1973 to up to 2023. I was just how the vegetation has declined and how the built up area has increased. This is what I was talking about. You can quantify it, how much it has done. Yeah, and water body changes through satellite imagery. Those who are from water resource management, or those who are looking into the surface water mapping and all, satellite imagery will help you to map. You can delineate the boundary. You can see a lot of changes happening with Bangalore. You can see that it's a sentinel, because it's not only NASA, European Space Agency, ESA is giving sentinel to information with the multi-spectral imageries. You can map it very clearly. You can delineate your water bodies here. Yeah. And initially it was 4 classes. Then I look into the binary, that is built up and non-built up. And you can see the expansion maps as well. You see here, initially 1973, because the same study area, I divided into 5 kilometer by 5 kilometer grids to do the micro level, to understand the micro level. Then you can see initially it was just a 4 grids, or around like this area was comes under the highest building density. But now in 2023, beyond the boundary, you can say this the boundary is up to here, but this is all the pixels, or all the grids were having highest building density. Yeah, and BBMP is already planned for this is a proposed BBMP area. So you can see how because this is not a solution, right? Expansion is happening. When the expansion happening, administrative boundaries change, like they are just delineating with a different area. But that is not the solution. You should identify how to resolve it. Okay, I'm just giving some hint here. Maybe the solution, or we can discuss in the last stages. And from my first objective, I understand that, okay, the center part of the Bangalore is over urbanized, and this is towards the transportation have some of the impact, and some of the highways or national highways has some of the impacts here. It is growing in this direction, or not direction. And there is so many statistical tools available to quantify it. You can see, because if this is the sender part, you can see exactly in which year these kind of, suppose we don't know about that city, what kind of infrastructure facilities as implemented, but still we can understand that, okay, suppose this is the area, suppose this particular year there is a lot of peak happened, that is building density has improved from this to this, then you can see that which grid exactly changes happen and which year these kind of a changes happen. So this is what we call it as a quantifying your urban expansion. That was my first objective. Then that helped me to frame my second objective is, now, okay, the condition I know, then I want to know the event triggered urbanization. That means what are the events caused these kind of urbanization? So what is the influencing factor for these kind of urbanization? So then, from the existing literature, from the newspapers, and from the previous years of art, I could identify the major events within Bangalore and the surrounding area. Even in the sense, if there is a one infrastructure or the airport construction itself is considered as a one event, because of that event, how the surrounding area or if the particular grid has changed. Yeah. So this is some of the Google Earth imageries, 1985 and 2020, 24, up to 2024, because Terminal 2 has inaugurated in 23-24 year. You can see this is a ground observation or ground Google ground imagery, and this is a classified imagery. You can see this is the entire even runway or the construction activities, all we can quantify it. So this is what we call it as a event triggered urbanization. Some of the events, if the event happened in the particular grid, how the surrounding area is changed, and before 5 years of that event, after 5 years of event, how the expansion happened. That was my second objective for my work. And now technology is there. I am from IIIT. We have a lot of tools. We have a lot of machine learning, deep learning, all the technologies are there. Then I want to see what will be the future for that area, because influencing factors we identified, we know the expansion. Then we have did some kind of, because this is the overall frame of urban growth modeling, because I work more on urban expansion, urban growth modeling. So any of your work, right? The problem can be anything. It can be from agriculture, it can be from water resource, any problem you can think. This loop will be there. Data source is one of the, but it can be satellite imagery, it can be any other organizations, or even it can be tabular information. That information with a time series data set and with the driving factors, we can build our prediction models, we can do trend analysis, and it is good for a sustainable urban development. In my case, it is a sustainable urban development. You can think about sustainable development goals. Within that 17 goals, you can think about your own problems. Yeah. So then I started my literature in more on urban growth. This is not new topic. This 1960s onward, 70s onward, these kind of urban growth modeling are existing. There you can see some of the categories. It was a simple urban growth model. Then later we integrated with a multiple other techniques and some cellular automata methods from the computer science background. Then we combined. Now we have a very good combined hybrid models to predict our future. Yeah, these are some of the literature, and these are some of the driving factor. And yeah, this is what I framed my urban growth model, because recently there is one patch land use simulation model to predict how the 2025 or how the short-term prediction and long-term prediction. And there is because in India, there is another problem, right? When you look into the influencing factor, that should be representative of the same year. Suppose you want to look into the population statistics of 2025, and it should be what are the driving factors we are injecting towards the urban growth model. It should be representative of the same year. That same year or the frequency is not up to the level of what we are from the national, like developing country like in India. So that was one drawback with the plus model. Yeah. Another model is STM, because without considering any driving factors, we are understanding the history, like how the spatial temporal pattern has changed over a period. Then based on the pattern analysis and based on that, we are predicting how the neighborhood area may changes. So that is what the STM model talks about. So, and through technology, we have because any kind of a machine learning models, you may work with a lot of features, right? A lot of influencing factor for that y or the dependent variable. So initially, it's not good idea to ingest all the driving factors or all the features into your model. The best approach is that you should identify what is the collinearity within your features, or which feature having the highest influence to your y, or what to predict. This is what we have done for our study. So you can quantify which influencing fact. The population has the highest impact in any kind of urban growth model. So this is some of the results from urban growth model. You can see North has some of the changes. North Bangalore has a lot of changes can happen in 2030, or even Whitefield have a lot of changes happen, or even Hosur side also. So I'm just talking about the regional area because I am very familiar with that. Because those who are not from the Bangalore, it may not be make sense. But I will show here some of the result here. 2025, if the study area, like for the entire study area, if the population is 29.88, it is going to be increased by 32%. Yeah. So it's going to be 32 point, around 33% of urban population is, so urbanization is going to happen in our study area. Then that is the overall picture of urbanization and urban growth modeling. Now we understand that transportation has some impact in these kind of urbanization. So I want to see how that open source softwares kind of a QGIS and all the other plugins can helpful for quantifying these kind of infrastructure. So there is a one graph theory, you may know, right? Like if it is a, you can see, because the transportation, the road networks have a kind of a graph theory approach. Like if you have a dead ends, you can call it as a nodes. If it is a junction, you can call it as a node. Or even simple road network, it's kind of a links or edges. So this is what, this is some kind of a graphs here I showed you. If this is the road network, what will be the connectivity? Is it higher, is it more or less? Just see this kind of a pattern. This is connectivity is much higher here, right? If the vehicle want to travel from this end to here, there is this continuity is here. But if suppose this is the case, there is a lot of dead end points. The vehicle cannot move much better. So this is the concept we have approached for understanding the connectivity of road network in Bangalore, because Bangalore have 198 wards. I want to know each ward, and I identify which ward have a highest connectivity, which does not have. So this is the approach we have taken. So this is what I was talking about, 198 wards. And this is a HSR layout, because the pilot study has done in HSR layout where I live, because I know the study. The better if you are from a particular city, you start your research from the same city. The curiosity will be there, because why this is happening, we know the location very well. So these kind of things will help you to deep into your research. And here, this is a lake we have. This is a military area. This is where my apartment stands. Yeah. I will show some of the results here. So this is the study area from OSM map, and this is the network we created from the simple shapefile. So these are some of the formulas you can quantify your connectivity, because it's better to have some measures. If it is 0 to 1, if the connectivity is 0, it's very clear that that area does not have any connectivity. If it is more than 0.8, it's approached to 1, you can see that area have a very good connection. But still, if the transportation or if there is some challenges, it may be due to some other reason, right? Yeah, these are the tools I have used to quantifying these kind of connectivity, coverage, and hierarchical map, because in India we don't have a proper hierarchical map. Primary road, secondary road, food, all these informations are not there. And even walkability is important factor, right? Any kind of a new construction or any kind of a business, they will look into the highest walkable area, which is it's a comfort zone, right? Then this is how we have done. Walkability is one factor. And the same study area, I was talking about the HSR area, right? This small grid, 30 square kilometer. I divided into 1 kilometer one, because grid level analysis will give us micro level information. You can see this green color, right, has the highest connectivity in beta. Some of the measures are existing to measure this connectivity. So this is what connectivity measures and coverage measures. Connectivity talks about the circuits. If the vehicle want to move around, if the network or if your roads are well connected, that connectivity is will be near to 1. This is coverage. Will talk about how much area it is covered. The total length of a road divided by the area will give you the coverage measures. Yeah, some of the interesting results you can see here. Center part of the city have a good connection, but the outskirt or the other area does not have much connections here. So this is another important research from our topological analysis. This is clear, right? Connectivity measures. Another thing, one interesting fact, out of 198, around 20% of the wards have a good connection. That means the remaining 75% of like that many wards does not have a good connection. From our results, we could do this. Then hierarchical map we produced from QGIS and we matched with OSM, because OSM you can see just a base map. You can, if you want, you should digitize and create your data set. That itself is time consuming, right? But through QGIS, we can prepare these kind of maps. You think about, if you are from water resource, you think about how to create these primary that channels, right? Think about that. These tools can be make utilized to identify primary channels, secondary channels in your research. Yeah. So walkability also, again, you can see which grid have a highest walkability. Yeah. Then I'll just conclude from my PhD work now within few minutes, because initially it was a settlement pattern, building intensity and all these things. Then second part was transportation. Now as a researcher, I thought like how we can think about how it is related, because we read many like wherever settlements are there, there will be a chance of road network. Wherever roads are there, there will be some kind of a settlement road network, or like the kind of a construction activities or buildings will be there. How these measures are related. So this is what we have done to model, because initially we did like we could see that many of the like in Bangalore it is over congested, over urbanized. Look into the some other small and medium sized cities in Karnataka and give some suggestions or suggestions to the government that if you want to build some kind of infrastructure, some IT support, look into the other cities. It's a growing cities. Then it should not be in the same way how Bangalore is built, because after a few years, if we are not planned properly, the situation is going to be the same for other cities as well. So we were more focused on how to plan a sustainable city development for other small and medium-sized cities in Karnataka. So this is the road network, and this is a settlement pattern from German Aerospace Department. And whatever research I have done, most of the research is more focused on open source data set and open source tools. Because if you want to like if you want to scale up to your city or other cities, it's easy to do now. Yeah. These are the blue dots are other cities. This is Kolar city in Bangalore. And not in Karnataka, it's very near to Bangalore. So any kind of a machine learning model with a 17 points or 17 records may not be sufficient to build your model. You all are from any kind of a data modeling part, right? Then we scale up into the entire nation. Around 505 cities we selected with a similar nature, similar number of population, with because we want to categorize into small and medium-sized towns. Then our model, I will show some of the results. This is actually generative models also we have used to simulate futuristic city. It is not a realistic city, but it's kind of a similar approach. Generative models we have used. Then OSM and settlement pattern from WSM, how these are related. And we quantify a lot of measures from these area, 505 records. Then we did some correlation analysis to quantify. I'm just wrapping up. So just because these kind of a research will help us, which area does not have a good connection, does not for the entire nation. So we can suggest government that how we can improve infrastructure facilities for this area. Yeah. So these are some of the results. And during my PhD, when I was submitting, there was one new article is released that Karnataka need more cities. That is the same thing from my PhD I was talking, right? Karnataka need more city and decentralization approach towards Karnataka. You can see it's like very skewed. And after my PhD, I was working more on urban climate and urban weather modeling, and now currently working multi-modal mobility solution. And because initially I was showing that initially I try to linkage from transportation and settlement. Now I link with weather, urban weather, and this one. So now these are some of the publications from the urban quality or urban weather related. And current challenges, everyone know in Bangalore, the transportation is the biggest challenge. So we work more on mobility initiative with the best, like how multimodal mobility solution for a mega regional things. Yeah. So this is some kind of a research work what I do. So you can connect me if you are interested to do any kind of research or something. If you I can help, you can contact me. That's it. Thank you. Thank you so much.
Thank you, Ms. Raisha. Now I invite Mosmi ma'am onto the stage to felicitate our guest today. I invite Ms. Raisha to please come onto the stage.
We have one more felicitation of our yesterday's session chair, Dr. P. Lalita. Please come over the stage. She was the session chair for 2 sessions, and she has done the very rigorous task today. There were 5 to 7 online presenters. So facing the all technical difficulties, coming sound this way, that way. So thank you so much, ma'am, for your time. No, ma'am.
Thank you all. Now we will proceed with the breakfast. We'll have a break now. I request everyone to have breakfast and communicate with your fellow participants. Thank you so much. Enjoy this networking break. Thank you. Keynote at 10:30, so be ready for that. Thank you all. Welcome back, everyone. Now we have a keynote session by Dr. Norma. We are glad to have Dr. Norma from Malaysia. Dr. Norma from the University of Malaysia earned her PhD in Industrial Computing Supercomputers from University of Malaysia. She has been recognized among the top 40 research excellence achievers at UTM and is the recipient of the Venus Distinguished Women Award. She also mentors the Sunshine Plus Plus program, inspiring many in the academic and research community. With extensive contributions, Dr. Norma has organized over 30 webinars annually, chaired 4 international conferences, and serves as chief editor of MSMK as well as member of the editorial board of 38 international journals. Her research expertise lies in big data analytics, high performance computing, nanotechnology, IoT, and AI-driven digital innovations from Industry 5.0. We are privileged to have here today. Now I invite Dr. Norma onto the stage. Let's give a big
Thank you, Ms. Chair. Young generation, Z generation of KL Ash University. Thank you introducing me, to the audience. I'm Associate Professor Dr. Norma Alias. My sharing knowledge here is how I'm using AI and the mathematical modeling called Geodesic Active Control Model for enhancing the geoinformation system images, all right, based on some knowledge on data science, artificial intelligence, mathematical modeling, and images. I'm from Mathematics Department and Research Fellow for Center of Engineering Education. Before this, my research center is a nanotechnology at University Technology Malaysia. Thing in your key. All right. All right. My focus here is all right, on the planetary constraint. All right. The focus more on the climate change. Energy. The ability to do our work, and the study is how living the organisms interact with their environment. The planetary constraint is referred to the 9 Earth system with their limitation, with their boundaries, including the climate change, energy, and ecosystem. So I focus on this because it's quite related to the temperature behavior increasing almost every year, right? So how we use this information to apply AI to use the data science, all right? When we talk about data, you have so many data, in terms of the variety, velocity, volume. The question here is it the data have their value to validate, has a vulnerability, to do research, and what is the weaknesses and the strength of data? This is the issue. Most of your data is come from images, all right? And you want to analyze the data based on these images. Right? Okay. Cannot function or can function? Can function. All right, so I'm a mathematician. So I'm at the first stage. In Malaysia, when we go to the other stage, they need the mathematical foundation. Mathematical foundation including the theorem with the proven and the theory to support your ideas and knowledge, all right? So in our case, we try, okay, to get the data from remote sensing and then apply AI and to solve the uncertain environment. Okay, before, okay, there is a lecturer about how we solve the problem, okay, on the transportation, climate change, and then the urban heat, urban area development, and others. So there is some strategic that you need to apply here. For example, you need to do the validation, you need to do the optimization, and then you need to apply the mathematical modeling as a fundamental to do other research on the implementation or empirical research. So we are under this stage, mathematical research, to support the implementation. Yeah. So what is the strength? Okay. Can we go to the next slide? All right. So now, okay, since you are very good in analyzing the problem, so we hope that this is the list of images that you are going to use. For example, SAR, LIDAR, okay? And then some of you are using Google Earth, all right, to detect the deforestation, urbanization, all right? And then the AI rule is very important because, okay, you can extract the data using some AI algorithm. I'm using CNN, or you can use ANN, support with the machine, SVM, reinforcement learning, and others. The boundary refinement, for example, I'm using mathematical modeling we call as a geodesic active control model. And the trend nowadays is LSTM, long short-term memory, because the data is very huge, the data is very big, and random forest, okay, one of the AI algorithm. And then the condition here is an uncertain, okay, quantification. So what is that? Okay, you need to have explainable AI. We call as a PIN. Okay, that is a lag. Okay, when we ignore the explainable AI to validate the algorithm that you are using, for example, LSTM, random forest, and support with the machine, right? So this is a strategy nowadays when we deal with the images, for example, Sentinel, ICSat-2, and SWOT, right? All right. So what is the AI data driven in remote sensing? Right. So I know some of you using NASA, okay, data, for example, MODIS, Landsat. Okay, today we learn about Landsat and how they will optimize your problem, and GISS. Some of you using ESA, for example, Sanitel 1, 2, 3, and there is a specific objective to predict, to monitoring, to trajectory your problem. Okay, the other one is they're using NOAA. Okay, some of them using PSL and CEI, and then JAZA, SCOM, and GSCOMS-W, right? So this is the latest database where you can buy or open source. Okay, you can get freely, or you can collaborate with the university to use this data. All right, so now what is the global sustainability, okay, for our research? The first is we need to do interconnected crisis. Okay, most of ours, okay, talking about climate change, biodiversity, energy transition, and ecology sustainability. And then this problem is very high resolution, need high resolution images. And then the problem is very complex, non-linear, and uncertainty. This is an issue that we are going to solve, all right? And we always deal with the very traditional rigor. For example, mathematical foundation rigor. This is a problem. So we can solve this problem by doing some paradigm shifted to answer the question, what works and why and how it works, using AI, artificial intelligence. Okay, we will ask a question, what is AI? Why we are using AI? Why are we not using statistic, stochastic, or others way. So in solve this problem, okay, there is a trend nowadays. Okay, what is the trend nowadays? From Scopus 2021 2025. Okay, you can see the trend here. What you do, all right, should be have a mathematical foundation. If not, your prediction will be wrong. Your argument is very wrong. And then the solutions will be wrong without the strong fundamental mathematics, all right? So where to get this data? First, you get the data from Scopus, import the data to the VOS view, and then you can get this, all right? From here, you can plan, what should I do? There is a graph theory here involved. There is the AI here. And then this is your application. And the latest one is upgrade the AI algorithm. You not focus a traditional CNN, ANN, SVM, random forest. You upgrade, okay, using the active function of that algorithm. Okay, now, what is the problem that we are going when we have the images? The first is a heuristical misconception. Right, the previous speaker said that when the urban create, when the city create, there is a heuristical, okay, the background, why the city developed, right? The second is a lack of data and understanding. You have so many data from many sources, but lack of the understanding, all right? In terms of the complex interaction and non-linear transition, and at the same time, there is a low probability. You know, in statistics, we need to find high probability, but there is some argument very low and high impact event. For example, is representing the policy decision making, is related to the issue of policy maker. All right, so there is some example, problem, misconcept, and then problem with the data itself, all right? For example, you can see here, AI data-driven can analyze the Greenland ice sheet. But what is the problem? Okay, there is a reach 1.5 to 2 warming and not 3 to 5 degrees Celsius because, you know, there is a climate change issue. There are so many examples, for example here, okay, the glacier is rated by over 40% in this decade, but we never realized this percent increasing almost every year. And then the other one you can see from the multi-data source data, okay, for example, you can get from SR, optical, or thermal with the AI model, allowed scientists to detect the emerging anomalies before they become visible through the rational method. So you have to know, this is a problem when we deal with the real data, all right? Okay, there are so many examples here. And you can see here, there is a differences between two images. Okay, in the system of AMOX, what is AMOC? AMOC is Atlantic Meridian overturning calculation, all right? This is a warmer, they predict the warmer world, okay, but the less information about the water and heat transfer, all right? They also have no information about the warm surface current driven. So the lack of the paramount, okay, parameter to predict an accurate result. So the mathematical modeling should be include all the parameters to predict. So you see, there is a different, very different between the weakness AMOX and the real AMOX, all right? All right, so the answer is based on this, all right? We can say that model that we use to support the system called AMOC is failure, all right? So you feel upset and then you say that my prediction can be questioned. So the global sustainability challenge now is required mathematical foundation, required theorem, required axiom, corollaries with the proven, and then the theory, okay, to support your foundation, all right? So you will say that how mathematicians do okay, what the important function. Okay, the important function, they give you ideas based on the axiom, theory, and then theorem to be support. Next, they are doing a proven. But some proven, okay, should be verified with the real data. Where the real data comes in is come from the images, all right? The list of images that I stated before. All right, so now, okay, they start do proven, but some proven is very weak. And how to make it strong? They need to do a list of proven, right? So because of that, they start using some component, for example, axiom, all right, lemma, theorem, and theory to support the database to verify, to validate the database. So this is an understanding rule that we need to know, but it's quite hard without mathematician help. So you will say that, oh, okay, I'm doing comparison. In the conference, we see there are so many comparisons between ANN, CNN, support vector machine, and then reinforcement learning, LSTM. And then towards the end, you said that LSTM is the best, okay, predict for the development of urban area. Anyway, it should be set up, okay, we start with the axiom, lemmas, theory, and conjectures. Okay, the other weaknesses, okay, is there is no what we call as explainable AI. In mathematics, we are using PIN, physics informed neural network. Maybe you are using start line. Okay, yesterday there is one of the presenter presenting line. So there are other software where this software can verify the AI that you are using, all right? AI that you are using is what? CNN, ANN, support vector machine, log, LSTM, and others, all right? So in teaching also, when you start teaching using AI, you need to have the explanation AI. I list you AI method. Okay, most of you now looking for deep learning. Why? Because you are using a big data. You are not focused on machine learning because your data is very big. It's not small, all right? For mathematician, there are so many tools. I'm using MATLAB, Maple, Mathematica. For paracomputing, I'm using CUDA. Why I involve paracomputing? Because the data is very huge. Why we say the data huge? Because the data is a terabyte, yottabyte, zettabyte, right? It's very huge. It's not gigabyte or terabyte, all right? So this is our problem. Some of you are using fluid dynamic. India, very famous with the model using fluid dynamic. The problem is, okay, they are not apply AI, they apply model, okay? Model is just for validation, okay? All right, so now let's go to the model-oriented. Okay, this is a model-oriented. Now we go to the data-oriented. Okay, what you are doing now, you are really focused on the classification, all right, and then categorization, forecasting, pattern recognition. That's what you're doing when you get the image. But you forgot to do the optimization. You believe on the AI algorithm based on the existing in open source. You can call Keras TensorFlow, all right? You can call Python, all right? But you need to do the optimization. For PhD level, you need to create a new AI or optimize AI based on the some argument. And then the action here is, of course, you want to do a policy, okay, you want to change policy, you enhance the policy, you want to do resources for educations and others. All right, beside that, okay, people are using optimization. For example, they're using dynamic optimization, multi-objective optimization, stochastic optimization to manage this uncertainty developed by the images. All right, so this is your problem. Okay, it's a climax. Maybe you are focused on the ecosystem in transport and others. All right, so please, okay, for PhD or postgraduate, okay, we need to have the novelty and contribution. All right. Okay, next. All right. So now, okay, let's focus the functional mathematics to support or to develop the good, okay, the very accurate AI algorithm based on the, for example, complexity theory, graph theory just now, proof theory, set theory, and others. How to get this? Okay, you need to collaborate with the people working with the model development with a strong, okay, mathematical foundation. Okay, that I put in the 3 layer, okay, which is very easy to understand. All right, the first is you're using mathematical analysis. I know you are quite familiar with the optimization theory, with the statistic, okay, process, with the fundamental analysis, all right, and then you apply. This is you, because you are dealing with the AI, artificial intelligence, you are dealing with the statistic model, you are also dealing the numerical method to support your computational algorithm. The last is optimization. This is a very important stage because you want your image high resolution. You want your image is very robust. You want to make the decision making. You want to do a forecast. You want to do the trajectories and others. All right, so now, okay, this is a time for you to do the data-oriented. I classify the 3 cases where you can do the data-oriented. One of them, statistic, very traditional. Now we're not using SPSS. We are not using AMOS. Stochastic, we can replace with the multimodal, or you can use some tool to support your stochastic optimization. And then machine learning. Machine learning is AI. Okay, some of you using deep learning, some of you using reinforcement learning, some of you using LSTM method because it's more on automated model building. All right, there are Python, Keras, TensorFlow, MATLAB, okay, and the Mathematica to support this. All right. For my student, we much more focus on the classification because we want to enhance the images to the high resolution to predict something. All right. But some of you are using clustering for the images, and we need to make sure, okay, the images whether supervised, labeled, on, and unlabeled. All right. So this is a comparison between the model and the data-oriented. Okay, this is a function of mathematics, model-oriented, and then this is the images that you get from the GIS, you get from the Google Earth, you can get from the Lasset and others. So you can see the differences. So mathematics is very important because they will minimize the risks, okay? And then you also have that the output also shows that what you are doing can be proof, can be a certain. Okay, you move from uncertain to a certain, okay, condition. All right. When we do the question, okay, when you do a climate change model, there are some questions you need to think. How we know, why is work, and how is work. In this case, okay, when you say that what is work, please do not forget about the explanation AI. I'm using PIN. Some of you using any software to validate the artificial intelligence, right? Okay, I give you one of the V-cycle framework on the climate model, what I'm doing now. All right, the first is I create the mathematical modeling. The second is I'm doing the complex story analysis. Second, I support the computational because, okay, the numerical should be supported by the computational, and then maybe here I'm using high performance computing or supercomputer or quantum computing. Now people looking for the quantum computing to support the huge simulation. All right, and then there are a level of the analysis. I'm using optimization theory to make sure the images, the high resolution can be predicted and variable. The next is I'm using explainable AI because I need to compare the algorithm that I'm used, okay? And we achieve the mathematical guarantee. AI will be stable, realistic, okay, and accurate, and then reliable, all right, converge to the approximation solution. And then the last is, we hope that what we are predict, okay, with the minimum error from the approximation and exact solution. All right, so this is the process what we do. All right, the last is a mathematical tool to support your approximation. Okay, approximation. Okay. All right, this is a AI. Okay, AI framework. Okay, to help you when you do a data treatment. The first is, okay, you do a system requirement. You redesign what you are going to achieve. And then next is apply machine learning. All right, in this, maybe you apply CNN. Most of you apply CNN. Do a data management and do a learning process. Some of you using 80% for learning, 20% for testing. All right, it depends on the database. And then this is a learning process, data implementation, enhance your model, do a very good verification and validation. And there is a learning for the verification, and towards the end, you can do the required for machine learning verification, performance, for example, sensitivity, confusion metric, specifications, performance in terms of the computational cost, run times, and others. But we suggest you to do one process. What's that? Learning process verification. When you want to make sure your predictions is very accurate, reliable, sustainable, and others. All right, what we can get. Okay, this is a process, okay, when we deal with AI. All right, so the important here, you do not miss a data verification, and then continuous improvement, because there are so many software nowadays in the market where you can use, okay, for the continuous improvement, or you can develop the apps. What we can get when we follow this process, you can see, all right, the accuracy increase up to 96.4%. When you use AI, make sure the accuracy should be above 95, all right? Okay, some of my students, they get 98, right? Some of them 97. But if you get 70, 80, meaning that the level of accuracy is similar to statistics, similar to mathematical modeling, all right? Why? Because you are deal with the raw data, real data. Data quality, 98%, and then the error, see? The error is reduced up to 2.1%, should be like that, all right? Okay, now, what is explanation AI? I'm using explanation AI to support my AI. Right? Why? Because, okay, this one is a lime. I saw one of your participant presenting lime, LIME, explanation, okay, to support some data using AI, all right? And then attention for visualization, very good visualization, and decision path tracing. So the stability 92.3%, the flexible, the flexible is a 89.7%. The comparisons is a 4.2 divided by 5. So this is the superior when you apply the explainable AI, right? So there is some of the analysis. The analysis of the explainable AI is for generate interpretable explanation and futures important. This is very important, right? Okay, I give you some interaction, okay, between AI and mathematics, explainable AI and AI, the sustainability of AI, mathematics and AI, explainable AI. All right, you can see here how important explainable AI, all right, because they want to make sure that the algorithm you develop is sustained, okay, sustained. Okay, some of you using AI algorithm, for example, you are using support vector machine, random forest method, LSTM method, all right? Why? Because you need to make sure that the stability, the convergence, the continuous process is very high rank, high rank. So now let's we support the literature review, what I'm addressed here. Okay, it's come from Garcia 2022, and then Zhang 2023, Petal 2022. All is about how they are using the AI for sustainability, and then mathematical modeling, graph theory for the sustainability critical infrastructures network. All right, the goal here is we want to make sure the algorithm or method or AI that we are using is a trustworthy and scalability, okay, to solve our problem, for example, in climate change, in energy, in ecosystem problem. All right, the important is the uncertain to the robust and verified solution based on the mathematical modeling, AI, and the explainable AI. All right, you have so many problems in remote sensing data, and then you can solve it, many solutions. Some of you using monitoring, some of you using product specification, you develop hardware, you develop software, all right? Some of you using a pattern, and then how you control the environment data. Okay, there are also support by mathematical modeling to validate the remote sensing data. Remote sensing is real data, modeling is a fundamental. So now the loop or the sustainable is based on how you get the data, collect the data, gathering the data, do some validation and refine improvement, okay, do data verification, and then towards the end, continuous improvement. This is a close of the loop. This is a cycle, okay, when you deal with the AI, when you use mathematical modeling to support your remote sensing data. So what is you're getting? I hope that accuracy will be increased, okay? Fidelity is also increased. Statistic significant is less than 0.001, all right? The uncertain bound is a plus minus 2.1, the confidence level 95% increase, all right? And when we compare between the mathematical modeling and then the hierarchical that we are proposed, all right, you can see the improvement is considered, okay, confident, okay, we can confident with the improvement, all right? So most of you looking for the accuracy, most of you looking for the theoretical guarantee, okay, some of you looking for the high performance computing, all right, with a low time or high speed up, all right, and then some of you looking for the scalability, right? And to support a big data simulation, when we transform image to the data, you will create a big data, all right? You can use high performance computing, where you can use supercomputer, distributed paracomputing system, or support or shared memory architecture. So some of you, when I talk with the participant here, they are connect between the graphic processing unit and center processing unit. You can use NVIDIA processor to support a big data. All right, some of you using cloud computing. All right, some of you using quantum computing. The latest one is a quantum computing because our journey to the neuromorphic computing. Okay, what is the future of the AI? Is a neuromorphic computing, right? So this is a quantum computing, not in Malaysia, cost very high, almost 2 million, but there is location in India. India have a big grant, okay, to develop the quantum computing, I heard, okay, from one of the research center. This is a quantum computing. We do a collaboration with Singapore because we are near to Singapore, around 5 kilometers from our university. So we use the quantum computing from Singapore. All right, this is a critical path. Okay, we hope that there is a interdisciplinary collaboration from remote sensing expert, image processing expert, okay, and others. All right, so what we do now, we hope that we put so much fund to support the collaboration because we are focused on the fundamental. Okay, we are focused on the fundamental. Okay, now let's contact to the important key that I want to address. How I'm using mathematical modeling, we call as a geodesic active control is a traditional, and how I'm using CNN, convolutional neural network, modified with the GSC, all right, and how we can find the limitation and the performance when we apply AI in model. Okay, our application is to see the land use, okay, river chain, and then how the urban increase at the Iskandar Putri Johor. This is a smart city area, all right, but there is a problem during COVID-19 in year 2020. All right, this is our problem. Okay, the problem is there is a rapid development region, okay, in the Iskandar Putri, Malaysia, and then we use the there is a labor intensive, high subjective, significant on the overestimation area. So this is a problem in Iskandar Putri. All right, we are using multi-temporal satellite data, and we hope that we can develop an accurate monitoring for the deforestation problem in Iskandar Putri. All right, the quality, okay, we hope that we can predict this, okay, by comparing between mathematical modeling and AI to trajectory the deforestation problem in Iskandar Putri. All right, so we do hybrid CNN, integrate with the geodesic active control model, and then we also, okay, for the geodesic active control model, we compare with the Chanvis, one of the estimated algorithm. All right, so why is work? This is one hierarchy that we need to answer. We are using CNN, all right, compared with the GSC, and then we found that, okay, there is a mathematical modeling involved. I will explain what is alpha and what is beta. Alpha, beta, gamma is like the controllability parameter, right? So the objective research, okay, that we want to predict here is how when we apply the simulation, okay, how we can do some analysis, and we hope that this output will help Iskandar Putri to plan for the next 5 years. All right, the issue is deforestation. Deforestation means that there are so many land chop, okay, the root, all right, that is, we call as a forest city, Mediri city, smart city initiative at the Iskandar Putri. And we have the satellite data from 1985 to 2023. All right, we try to analyze this, and of course, we using faster processing on high performance computing. All right, when we refer to the trend, research trend from 2020 to 2023, okay, we can see that there are very clear here. We need to use AI, okay, to support this problem. And then we need to use images from remote sensing or satellite imagery. And our problem is to investigate the climate change. All right, we are using deep learning because the data is very huge, okay? So from here, we also said that when we use a deforestation, okay, again, we have this visualization, all right? When we apply GIS, Geoinformation System here, right? We go to the green color, the latest trend is developing the algorithm of AI. And then when we use GIS, okay, we need not far from the optimized remote sensing algorithm, by using artificial intelligence. So this is what we are doing. We are focuses a database from Scopus or Web of Science. All right. Okay, here. Okay, so means that GIS are bridging when we start the journey. So this is a latest trend nowadays. Okay, we need to use a database from the latest images and develop the algorithm. All right, so now this is journey. As a mathematician, there is a very fast journey nowadays to the AI. All right, if not, we are still in the mathematical foundation. All right, so again, we need to enhance the algorithm. So the motivation here is what? All right, we developed the hybrid CNN and GSC model. Okay, from that motivation also, we are using Python because open source, free software we can get from that. And then the next generation is the Earth observations capabilities and sustainable development goal. All right, there are few development goals that we are going to achieve. So we are using chain-based model to overestimate issue with the complex boundaries because we are using image segmentation. All right, so now there is some methodologies innovation here. We hope that the result is convincing, especially when we focus on the mathematical modeling to support the fitness of the images, the control external forces of the images, all right, the boundary adaptation using the curve evaluation. So we are very interested on the curve, right? So now this is the some mathematical modeling that we are focused here. Okay, we are using internal energy, right, for this equation, this integral alpha, all right, C prime S squared plus beta and C prime prime S squared ds. So it's this integral. Why I'm using integral? Because it's depend on the area, okay, area. So what is CS is a parametric representing of the curve. So nowadays we need to apply some paramount, okay, paramount estimation. Okay, the other one is internal energy or image force. So this is mathematical modeling. So we need to know the gradient of the image. We need to know the age indicator. All right, we hope that the process of image processing using mathematical modeling is convincing. All right, so we have alpha, beta, and gamma because we can see that the segmented can be extend. Okay, we can control it. Okay, we can control it. And then this is a basic JSC model. Again, this is a parameter that we are involved in our mathematical modeling development. And it is a chain-based CS model. We are using weighted parameter. Why? Because this will control the process of the estimation. All right, the next is we apply deep learning or machine learning, all right, or reinforcement learning, or LSTM, all right, to compare, okay, the mathematical modeling that we are developed. So the motivation here is machine learning or deep learning, okay, can be classified our problem. I know you're quite familiar, okay, when you apply convolutional neural network, there are three processes. The first is a convolutional layers, second is a pooling layers, and then the third is a fully connection layers, right? So now we do three process: pre-processing, post-processing, and do a data visualization. Okay, the segmentation technique that we are developed here is a CNN and their competitor, okay, their comparison algorithm. Okay, this is the software that we are using. Some of you using Python. Of course, when you're using Python, you can use NumPy, TensorFlow, Keras, and others. And then the process is real time, all right? This is what we are always implement, all right? So based on this, when we deal image segmentation, okay, we go to the green color. Green color, deep learning, image segmentation, 3D, reconstruction, because some image is in 2D, we develop in 3D. So deforestation is a bridging, okay, in this research. Okay, image segmentation here. Okay, when I click image segmentation, okay, what we do, we go for the green color. I'm always go to the letters. There is a complex network, all right, complex network. Now we call as a quantum network, okay, hybrid network. Okay, the deep learning, okay, some of you using UNet, okay, because UNet has a full memories, okay, and libraries, all right. This is a model verification that we are using for a trend, okay, data that we get from 1985 2023. So what we detect, okay, there is a minimal deforestation, 1.19%, and then significant increase up to 33.86%. The peak, the deforestation is 41.69%, right? The validation that we are using is CNN, geoinformation system, and local progression matching with the urbanization policies, and the policy impact is through the temporal analysis. Okay, you can see here there are so many improvement, okay, based on the existing data. The important here is accuracy, right? 56.67%, and then the performance indicator here is we have speed processing, preciseness. Okay, we can reduce the fault positions. This is one of the big data analytics, okay, indicator. Boundary definition is enhance the quantum accuracy for the irregular shape. We have so many types of the curve, right? So we can do a comparison between the Canvas and CNN, all right? For here, the CNN GSC able to have many pixels, big data, all right? And then the accuracy also increasing compared to the others method. And the contribution here, all right, you can say that by combining CNN and GSC, okay, we can predict the deforestation at the Iskandar Putri. We also apply the open source, okay, because it's free and able to be one of the methodology innovation. And heuristical, you can see here, okay, the development of Iskandar Putri easily clear from 1985, 2023. Deforested area can be detected over this year. And then the graph shows that, you see, from 2020 to 2025, okay, there is a minimum deforestation. Why? Compared to the year 1985 to 2010. Why? Okay, because of the COVID-19. We have a problem during the COVID-19. Iskandar Putri developed slow, all right? And then the issue is people from Singapore to buy the apartment, condominium in Iskandar Putri also reduced number. Why? Because political issue, all right? And as you see here, I can say that, okay, CNN and GSC is accurate for to analyze the holistical deforestation at Iskandar Putri from 38 years period. And we also have that, okay, this is a real world socio-economic driver. So we believe that, okay, we need to do something at the Iskandar Putri because most of the condominium still have no, okay, owner, right? And then the loan also increasing, all right, increasing. And then the price of the condominium decreasing, right, because of the because of the loan issues, okay, in the bank. So we hope that by the concept of optimization, right, we are using AI optimization. We can support, we can solve a large scale problem. We can do a real-time processing. We can analyze images from the sensor, from the SAR, from LIDAR and others, pattern of the images nowadays. So you can see this is a recent publication from 2023, 2025 about the deforestation issues. All right, okay. We hope that, okay, we can achieve all the sustainable development goal, sustainable development number 15, 11, and 13, right? So because, okay, this is very important for the developing country like Malaysia. And we enhance the accuracy, okay, we also enhance the computational using high performance computing, okay, we initiate one of the research methodology on deforestation monitoring using combination between CNN and GSC. All right. Okay, as a conclusion, okay, we can say that deforestation at the Iskandar Poultry we can analyze it using big data analytics, and we can see the pattern from 1985 to 2023, and then how its impact to the urbanization policies, national economy situation, and political reasoning, right? So we hope that, okay, by using the mathematical low cost but high potential, okay, we solve the problem fundamentally, right? And as a conclusion, we hope that by integrating between AI and remote sensing, all right, we can solve all the problem, especially in mathematical rigor, and we cannot, okay, this is a non-negotiable condition. And then the second is a data-rich environment provided by the remote sensing. It's very effective, okay, to verify, to validate, okay, our problem. And the data-driven is involved in the paramount framework for the optimization that we proved already using the big data analytics, and provide that we develop the AI algorithm, okay, with the fundamental mathematics, because we believe that mathematics is a next generation for sustainable AI, right? So thank you very much. Any question? No question?
Thank you, Dr. Norma. Now, following the keynote, we have a panel discussion. Before that, I want all the participants who are ready with their posters to please make your preparations in the lobby. Please report to the lobby and make your preparations for poster presentation. I request all the participants to report to the lobby, and whoever are participating in poster presentation, please report to the lobby and make your preparations for poster presentation. Now we have a panel discussion led by Dr. Sai Sudha. She'll be joined by the following members, our chief guests, Dr. Norma and Dr. Bahari Mahat, and also Radha Krishna, HR Head, KL University, Hyderabad. I request all the participants who are ready with their posters, please report to the lobby and make your preparations for poster presentation. I invite Dr. Norma, Dr. Bohari Mahat, and also Mr. Radha Krishna onto the stage, and also Dr. Sai Sudha.
So, good morning, one and all. Um I could see a great energy in the attendees and presenters in the conference. Your involvement was truly commendable. And today I was there for a few of the sessions, and I have seen some of the presenters who are really presenting well. It made me feel like I'm taught the entire subject in the single presentation. So it was really nice. And I'm Dr. Sai Sudha Gadde, Faculty of Computer Science at this campus. And I'm an advisor of IEEE Group, Affinity Group. So as part of IEEE Women Engineering Group, it is a dynamic force dedicated to revolutionizing the landscape of engineering and technology by championing the achievements and potential of women. So we are at the forefront of a global movement, passionately committed to not only inspire the next generation of innovators through transformative outreach programs, but also empowering current professionals with unparalleled networking opportunities. So our group serves as a powerful incubator for leadership, a vibrant community for collaboration, and a relentless advocate for diversity, ensuring that women have every opportunity to lead, innovate, and excel in a field of their interest. So as part of this group, Affinity Group, we are hosting a panel discussion today. And the topic of the discussion is the hardest mile. So navigating the obstacles to your dreams. So as part of this, we have three panelists here. And first panelist, Dr. Norma Binti Alias. She's a distinguished academic and research fellow at University Technology, Malaysia. And Mr. Bohari Mahat is a professional affiliated to Sanbo Pontian, Malaysia. Mr. Radha Krishna Virla, the manager of human resources at our campus, KL University. So I welcome all the three panelists today. And now as we move on to our panel discussion, I would like to pose a few questions to our distinguished guests. These questions are designed to explore how they have navigated real-life obstacles, offering us valuable insights from their personal and professional careers. So thank you so much for attending this, and we'll proceed for the panel discussion. So welcome all of you once again. Thank you, sir. Thank you for accepting the invite. And First, I would like to ask to Dr. Norma, ma'am, what was the single toughest obstacle you faced in your journey, and what specific action did you take to overcome it?
Thank you, the chair of this forum, because inviting me in this forum, which is very important to spite our motivation, right? So what is the lower point in my life, okay? The lower point when we have a problem, okay? The big problem when my father passed away and I need to survive, okay? From school to university alone, right? Without parents. This is a low. And then the highest is I have a lot of motivation from friends. I lot getting a help from lecturers, from teachers, all right? And Alhamdulillah, all right, they inspired me to be what I want, okay? Yes, we have a strong mind. Okay, as a mathematician, you also from engineering, STEM, you are using left brain so much compared to right brain, right? Left brain is more logic. Center of the brain is a connection between left brain and right brain, right? So on left brain, we learn about mathematical thinking, logic thinking, reasoning thinking. All right. So you know what happened. Okay, okay. What happened to me? I need to find the source. Why it's happened? How to solve it? And at the same time, we are also have a good strength on computational thinking. Am I right? Algorithm development thinking. I just explained today about what we are doing now should be verified. So that's we call algorithm thinking. All right. So we so much work on left brain. On the right brain is more on the abstract. Okay. I know people from India. Okay, they are much more working on right brain, right? The East country like Japan, Korea, China, they're working so much on left brain. They develop their nation, all right, using too much on left brain, all right? So, right brain is very important, balance with the left brain to make more success. So when I have a low point, okay, meaning that my motivation is very low, I need help from the community, from my family, from my friends, from my close friend, from husband, from lecturer, all right? So that's we need help. And as Muslim, of course, I need help from God, from Allah subhanahu wa ta'ala. You are Hindu, you also have your own God. You're also asking God to help you. So this is a low point to up point, all right? Okay, thank you.
Thank you so much, ma'am. And I just want to know your life experience also, like your insight on the same question. Do I have to repeat, sir? What was the single toughest obstacle you faced on your journey, and what specific action did you take to overcome it? Like,
Thank you, Chair, and thank you for inviting me to this sharing my knowledge regarding what happened. Okay, I remember what my parents told me that, you see, when you start work, you have problems to find your you find your cash money. Always you have a problem to have a problem, but the problems you should to take handling with a professional way. Because anywhere have a problems, in a jobs where you go, problems always come to you. Although you do the business also, we do not know who's your client, and we do not know who's your partner is. Okay, when I'm through it myself, I actually have a big problem mostly, but I handle in professional way. I have a friend, a group friends, to discussion with me, with a developer, owner of the developer. He a very good businessman, and informed me that I need to do a business early. You should do early business. Not now you to meet him. The problem you told him, you have the problems. This is, you see, what I'm coming through, my problems always I do in professional way. What we have around here, okay? Don't do in a rough way, wrong way. Things with your friend, your close friend, to do discussions to get the better result. Without any result, you need to think yourself. Problem where you go, I think you have most lecturer here, master, PhD, we have problem about a job. Okay, what you think when you have problem with this matter? I think thousands of the university now, when after degree they've completed, they have more problems. In Indian university, they have more popular to after they have completed their study. One university have 4,000 students will out leave the university. How many university in India have? Same like in Malaysia. This is, you should think in professional way to find the job, what you have to do. If you think way to do your business, you should do the professional business. That's all. Thank you very much.
Thank you so much, sir. So I just want to know the perspective of the third panelist also.
Thank you so much, ma'am. This is Radha Krishna. I'm heading HR for KL University. I had 13 years of experience. The toughest obstacle in my real-time journey along all these 13 years, dealing with people. My job is to deal with the people. Actually, so many people like with different mindsets, different expectations, and different, even egos, they comes with me. They need a good solution, a satisfied solution from them, from me. They look at me and I really, sometimes I feel pressure and sometimes I feel really nervous. But what helps me to overcome, I learn to pause and also listen deeply what the concern is. And also I never react immediately for the concern. I took some time and also I'll discuss myself. And, I build, over the time I build the patience and also the confidence. And definitely always I, give them a fair, the fair answers and the fair to all the people who have been approached to me. And also I believe that the time, the consistency, and the empathy definitely turn all the negative or the most difficult situations into opportunities to build the trust. This I always feel that.
So I got excellent answers from each of the panelists. Like ma'am said, we need to distinguish between how a left brain and right brain works. And it's really very good. And sir also addressed Mahat sir regarding how well we have to work in a professional manner, even if it is a business also. And Radhakrishna sir also addressed his own experiences, how he has overcome all the obstacles. It's really inspiring. And I go with the second question to Mr. Bohari sir. And how did you deal with self-doubt and external negativity when you were at your lowest point?
Okay, this is very upset for me, my life. When I do my business coming down, I feel down. Take years to settle it back $1,000 gone to the drains. You see, this happened to me when I was think that I was run away back to work to get my own work. You see, always I think when I do the business, I always think, can I get same payment or not? What I get every month. You see, this is the challenge when you do a business. A very big business you do, sometimes you win or you lose. Okay, I always doing professional way. When I have this business down, I have a good friends, discussions back. Okay, we have a good, when you have the friends, there's a friend to give you. Don't have a wrong friends. Friend, when you're happy, they were lost after that. When you suffer it, you down, they will not come to you. See, what I'm doing now, I have a very good friends, all the business guy, have informed me that, motivation me, go around, you need to go on your business. The business always have for you. See, what I'm doing, I have a lot of business. I'm doing engineering, okay? I'm doing for moving company to do the aspect people come to Singapore. I deal them, their furniture, hang them machines, electricals, and CV, because you sometimes expect people come in Singapore, they mostly they use 1110. The voltage is different. If you're wrong to plug in, I think the system start all bursting because the different way. This is a we learn professional skill we have, you see. This is the thing I have. You all, when you have the business, you think. You need to think what you get it now. If you're a professor, maybe you get more than 15,000 a month. You should take, when you do a business, you must get 30,000 per month. If you get a lower for the business price that you get it, better you to pull back. You can't successful if you're wrong friend. It's not easy when you feel down, when your business down, to think twice where to go. I'm doing my business. I'm an instructor also, teaching people to protection officer. That's in my business, security. I teaching people to do bodyguards and everything. Because when you do the business, every business you can go in. Engineering, to doing a turbine machine, boiler. I have a license with IC turbine engine. I have a license with a boiler first class, more 1,000 watt. What happened to your, when yesterday I sit down, your light come down, that's it. I have a generator around here. Maybe you're using a small generator. It's not full up the bed to back up your currents. This is my business. I do everything. Okay, I hope that when your business down, don't feel bad. Try to find another business. It's not only one road. You have two roads to go. Okay, thank you very much.
Thank you so much, sir. And I just want to know the perspective of the same question from Mr. Radhakrishna, sir, also.
Thank you, ma'am. At my lowest point, actually, everyone has their own concerns, and also, I always, everyone has their own loved people and trusted people. I always maintain a positive people around me, and have few people and few friends professionally. I always discuss with them regarding if it is professional. I have a set of people. I'll talk with them, and definitely they spread only the positive vibes, and I regain my clarity and confidence. What I'm discussing, what I am, where I'm at, the point where I'm at low, and I settle down with the same.
Thank you, sir. And then I want to know about Dr. Norma ma'am's perspective too.
When your friend die one by one in a few months, what do you feel? Something wrong in the lab or in the office or in your environment problem. Am I right? It's happened to me. one of my close friend near to my room, okay, behind of my room, in front of my room, pass away one by one. I'm very sad at that moment, all right? And then towards the end, after a few years, I realized something happened to the environment. So I make some action, all right? So, and of course, it's not some of parties accept my action, some of them reject my action. So I go alone, all right? But there is a supportive people, okay, to make a clear action. So this is a condition for me where I move on. It's not, nowadays there is no problem, okay, what we are doing, what we're dealing now, no people die, right? We are not from war country. We are come from successful country, all right? Malaysia, very successful country, calm countries. So the important now just to work with, for example, my career. I'm a researcher. The same time, I'm also a lecturer. So I just fight with myself, my knowledge, my weaknesses, my strength, all right? And then my resources, for example, fund, all right? This is how we can pay for our student. And this is the journey that we need to go, all right? So I just remind myself, I'm not from the country, war country or jobless country, okay, problem countries, all right? So the important now, I just improve myself based on the knowledge, based on the motivation, and then the strength, and try to minimize my weaknesses. My weaknesses is very quiet. Okay, why quiet? Because very easy to get information, especially in nowadays AI, artificial intelligence, AI generative. I know some of you, okay, never go to other place, but very familiar the place by asking information from AI generative. So you are very quiet, stay alone in your room, and then you are doing personalized learning. Am I right? Yes, all right? So that's develop yourself. So once you escape this technology, AI, Internet of Things, all right? And then some more Educator 4.0 software, apps and others, you escape yourself from the development, from the people who are very advanced with the technologies, right? So please, okay, together, okay, with the university, nowadays people looking for the AI in teaching and learning, not just AI in research, all right? And quite what we call familiar with the education 4.0, okay, meeting online and worldwide friend, right? My friend is not in India, in other countries. Okay, now I'm in sabbatical leave. I'm not staying in one country. Last time I'm staying in one country, one university. But this time, my sabbatical leave, I go to 16 universities across 8 countries, right? Why? Because I want to know people, all right? I want to know their technologies. I want to know how they're using AI, Educator 4.0, for survival as a lecturer, as a researcher, and as a businessman, all right? So this is very important nowadays, okay, to develop a strength. And of course, even though I'm quiet, okay, but AI develop personalized, okay, of myself. All right, thank you.
Very inspiring answer, ma'am. And we got a very good answer for this question also from each of the panelists, mentioning that having a very good friend who could support in your lowest time is very important. And how she could also manage when something happened to their friends over one by one and all. It's really impressive. And traveling few countries from last few months is not so easy. So out of the home, she is working very hard to learn all the latest technologies, and which is very impressive. So thank you all the panelists. And another question I have, last question. And this is to first to Mr. Radha sir. Looking back, what's a mistake made that you now see as a crucial turning point and learning experience?
Uh, Actually, in 2017, I was blessed with a baby girl. And the same time, after 2 days or 3 days, I got an opportunity from Tech. I'm working in Tech Mahindra at the time. I get an opportunity with an increment, promotion, and transfer. And I don't want to take that because of, and I was working with Provident Fund things, and I have to go for Pune all the time. Even I travel monthly twice or thrice, but I have to, I take a decision. I don't want to be transferred to Pune. So I resigned there. And after some time, I get an opportunity in KL University in 2017, where it was started in Hyderabad. And I started my career as executive HR, and I'm heading HR here. And this is a crucial point where I have taken, the decision to, totally U-turn from corporate to academics. And initially, I felt really, bad. But if I am in Tech Mahindra, or my colleagues who are working still there, they are senior business partners in HR. But now I'm leading the department HR. This is the main thing, the setback for me.
Very good, sir. Very nice explanation. And the same question to Mr.
Okay, thank you, Chair. Okay, my mistakes, when the mistakes happening, okay, when we have finished, completed our study, correct? Degree, master, PhD. Okay. Sometimes we start work, we don't think about that anymore, correct? We are mistakes, we didn't think about education anymore when we have completed our degree, our master, our PhD. Okay. Education is very important normally. As always change until our age, we need to study. Okay, that's an important for our mistakes when we come. When you are professor, you are helper, you need that education is very important. Although you do a business thing also, education, we need to improve our new model coming every year. Exchange AI, maybe we do not know. Coming soon is what? Every year they change. We have a professional scientists, people in the world, they always change. When I put up myself, okay, I upgrade my skill for my upgradings, my professional engineer skill to successful myself, okay. That's the thing I have my knowledge to do business, what I have now myself. I'm trust myself. I can do everything. When I start to upgrade every year, my goal, important my goal. Every year I must go study. First I from my study, first I come to buildings. We Singapore bought SDB. I doing for the building, a culture that things, how to build the building, condominiums, everything. After that, I take electrical. I take my steam boiler. I take the IC engine, and I go to welding. This is more skill, everything I go, until I get professionals, engineering, professional skill I have now. You see, I did not know when I have met one professor, he told me that he teaching electrical. He cannot dismantle light, his own home. I'm surprised. How can he's a professor? He can handle his own house with electrical because he only know the theory, only, not in practical. You see, for me, I need to have theory. Must have hand showing the thing. Thank you very much.
Thank you so much, sir. And lastly, I just want to ask Dr. Norma ma'am regarding what's a mistake you made that you now see as a crucial turning point or learning experience?
dear my son and daughter. Actually, I'm older than you. Now I'm 57. So you are considered my daughter or maybe my son. All right. The first is mental block. Okay. Break the wall. All right. Break the wall. Why? When I married Singaporean, Bohari, so my mental block break. Okay. Because I'm Malaysian. Malaysian is more traditional, more religious. Okay. And we are in the safe side. Okay. We are in comfort zone, in the comfort zone. All right. When I married Bohari, all right, he teach me, okay, about the future, about the goal. All right. So at age 45, he managed to have a goal. I'm a lecturer. I don't know what is my goal because I'm teaching. I'm government servant. So, but he teach me what is a goal. Be a good researcher. Be 40 researcher, the best researcher in in my university. All right, get a good position. So I try. Okay, so we need to break the wall. Okay, where make your mind close. All right, make your mind very static, not dynamic. All right, and then the important is how you deal with the student, with the client. All right, I try to make the relationship for the long time period. For example, I and Prof. Mosmi, we know each other since 20 years ago, meaning that in 2009, 2010, we know each other. So we make sure the relationships close until now. This is very important, all right? And then the next is respect each other, all right? And then treat our student as our family. Our student as our family. And then our student as our son, our daughter. This is very important because, okay, to make sure the career is prolonged. Okay, thank you.
Thank you so much, ma'am. And as a conclusion for this question also, it was really good listening to their own experiences and what are the turning points in their life. And even while choosing a career, obviously everyone will be having a dream career, and by chance they will come to some other career, like maybe being a software engineer or being in a business or being an educationist may not be chosen from the beginning. So by their path or their academic profile, they have to come to that particular stage. But still, the best part is we all love our career. So wherever we are, whatever job we are doing, we are loving it and we are giving the best for it. So I also felt the same, like I never decided to be a teacher from my childhood, or even I never dreamt of. But definitely my parents felt that she will be a doctor. But doctor, not a person who treats patients, but who deals with the students and scholars. Definitely, I am so happy for that. And I am enjoying my profession. And wherever I am, what ma'am said was correctly said, apt, 100% correct. I agree with her because when we deal with students by feeling that they are our own kids and they are our own family, then only we'll try to give 100% or more than 100% to them. So definitely we'll go out of the box and help them for everything without timings. And there are times where I have joined Google Meet at 12:30 for project review to my student also. In the night, they also have that courage to ask me to join Google Meet, ma'am, please, so that we have to submit by tomorrow. So please review our paper. So this kind of things also happen just because we feel them as a family. We have that personal time also given to them. So thank you so much to all the panelists. We have heard a lot about you and your experiences, and we learned a lot. And I personally also have an appreciation to Mahat sir, because he has encouraged ma'am, as she said. He was behind her, like in every part of her success. So we also need such inspiration from men also. So thank you all the panelists. Thank you so much. So we'll have a felicitation for Mr. Radhakrishna sir. Yes.
I request Mahad sir to felicitate him. आप उतर जाइए. Come. I request Professor Norma to felicitate our moderator, Dr. Sai Sudha Madam. She has done a very wonderful job. And thank you so much, ma'am, for your valuable time. And thank you so much, Radhakrishna sir. He is heading our 4 campuses across Hyderabad. And the way he was saying the tough time he faced to interact with the people, it is really being an HR, it is a very tough time to deal with their expectations and others. Thank you. Thank you so much, everyone.
So finally, I thank all the participants who are there in this particular panel discussion. And it's all credit goes to Mosmi ma'am who gave me time for this event. So thank you so much, ma'am. Thank you. Thank you.
Next, we have TCS Research Talk. Before we invite, I request everyone to, if you're interested, to please go, and you can go and know about them in their booth. It is outside the auditorium. You can visit their booth. And now for TCS Research Talk, I invite Mr. Shriyan onto the stage. Yeah.
So hi everyone, I am Shreyan Jaswal. I'm currently working as a researcher in TCS Research, and we are sponsoring this event. And so, first of all, I would like to thank KL University for giving us this opportunity to present our talk. So, so as you can see on the screen, we have remote sensing for sustainability, Earth and beyond. So by sustainability, we all, when we hear the word sustainability, the first thing which comes into our mind is the efficient utilization of natural resources, so that we optimally utilize the resources in such a way that not only does it satisfy all of our needs, but also we are preserving them for the future generations. So this is the main, we can say, the goal of sustainability or any sustainable development. So this, our TCS research, we are actually based in a lot of areas. And TCS, you would know, we are the largest IT company in India. So the TCS research, at TCS research, what we do is we are we have closely tied up with a lot of premier institutions around the country and across the globe. And we are not only doing industrial research, but we are also doing academic level research in various areas, ranging from robotics to embedded devices to data and decision sciences, life sciences, and whatnot. So whatever you can think, whatever area you can think, we are doing, we would probably have a team and we would be like doing research in that area. So we are from the Embedded Devices and Intelligence Systems team, myself and my colleague Ushashi Chaudhary, and we are basically, our team's main focus is on remote sensing. So a lot of things have been discussed about remote sensing. We all know what remote sensing is. So this is the outline of our presentation today. So first we will discuss remote sensing for urban sustainability, and we would also discuss remote sensing for urban metabolism. And if time permits, then we would also discuss some imaging spectroscopy, not only for detection of urban materials, but also the study of celestial objects. So can we move to the next slide? Yeah. So when you look at this diagram, what do you see? So can anyone like comprehend what is happening in this image? So this is basically, this is a city. So as we can say, a lot of complex processes are going on and they are interacting with each other in a, and our goal is to model all these complex interactions in the form of some model. So as it is written in the slide as well, our goal is to understand the complex interaction between a city and its surroundings. So can we move to the next slide? So now this slide you see and the previous slide that you see, so you can say that the complex processes, whatever those complex processes were, we have tried to model them in the form of a system. So this is the systemic view of a city, systematic view of a city. And as you can see, the can you hide this at the no? Yeah, thanks. So as you can see the legend at the like at below. So this red color we can say we can define as a risk. The green color the dark green color we can define as resilience against that risk. The light green color are the benefits, and this light red color are the burden. So in a city, there is an enterprise. Suppose there is an enterprise, and so what all would the enterprise produce? It would be producing products, it would be producing employment, it would be producing compensation for the shareholders, but at the same time, it would be producing pollutants, air pollutants, water pollutants, soil pollutants. Also, it would be consuming natural resources. It would be consuming water, it would be consuming land, it would be consuming a lot of natural resources. So this is the interaction between the natural resources, the pollutants, the enterprise, and the products or the employment that it is generating. And we have tried to model that in form of this block diagram. And as you can see, there are some external threats. So what would be those external threats? They would be hazards, natural hazards. They can be earthquakes. They can be anything, landslides that would directly threaten the enterprise. And if they threaten the enterprise, they would directly affect the products, the employment, and the compensation that the enterprise is generating. So modeling these external threats is a critical task, and this is also part of what we are doing at TCS Research. So can you just... So for modeling enterprise, we are working on a digital twin, the digital twin of urban metabolism. And some of you who might have visited the booth, you would have seen a poster that was our work on digital twin. For modeling the external threats, we are using susceptibility mapping. As we all know what risk or susceptibility are, it has been also discussed in this event. So our, can you move to the next slide? So risk models and hazard models, there is a slight difference between both of them, but mostly they are the same. Hazard is just like monitoring the susceptibility of a place, and risk is like the overall risk, which encompasses a lot of other factors. So, and AHP engine, I don't know if you guys are aware about AHP engine or not. So AHP stands for Analytical Hierarchy Process. So AHP engine is just a placeholder for any expert-based model that we would be creating of these external threats, as well as the utilization, or we can say the consumption of these natural resources. And for modeling this emission of air, water, soil pollutants, we also are working on pollution detection models. So these are the 5 areas that we are working on briefly in our group. Next slide. So this is basically the outline of what we do at our group. So M1, M2, M3, and M4, these are like this is our own nomenclature. So for M1, if we are generating a land use or land cover classification from an image, so that image can be a RGB image, that can be a remotely sensed multispectral image, or even hyperspectral image. So if we are generating land use or land cover models, maps from that image, all of those fall under the M1 models. For M2, suppose we have an image, a remotely sensed image, and we are generating or we are quantifying the amount of particulate matters that are present in that image. So can you like go back? So all of those quantification models, they fall under the M2. And M3 are basically growth models. So let's say we have an image, we have a land use or land cover image, and we are doing change detection for that image. How that place would look like after, let's say, 5 years or 10 years. So all those models, growth models as we call them, they fall under M3. And the M4 biophysical models, we already have a land use, land cover map. And through those land use, land cover map, we are actually quantifying the amount of PM particulate matters that are present in that image. So yeah. So for enterprise, we are using these 4 models, M1, M2, M3, and M4. And for the modeling those external threats, as I talked about earlier, we are using risk mapping. And for risk mapping, we have like a lot of different factors. All of these are like individually obtained by either remote sensing, or we have to do ground surveys, field surveys. Some of them are like we are generating the landslide prediction score. We are generating the like these are different layers: land cover, rainfall, lithology, distance to road. They can be like multiple such layers, and the end product would be a risk map. So this is what this work is also we are doing, as well as we are quantifying these external threats in the form of a risk map. So can we move to the next slide? Yeah, so this is an example of a M1 model which we are using. So as you can see, this is a remotely sensed image of a multispectral satellite. And by using machine learning or classical classifiers, let's say SVM, or more deep learning based classifier like deep fully connected neural networks, we are generating the land use or land cover maps. So such kind of all such models, they fall under M1. So can you move to the next slide? Yeah. So M4 models. So let's say there is a good example. Let's say we want to calculate, or we want to estimate the CO2 in a city. So this is a approximated formula. So CO2 in metric tons would be nearly equal to 9,000 into built up areas, which is in kilometers square, plus 1.6 into population of that place. So this is a mathematical model. So we have learned this model through, sorry. So we have learned this model through some statistical inference, and this we are validating it using the various data which is provided to us by, let's say, MODIS. MODIS also like records all the pollutants and their concentration at various times. So this is an example of a M3. M3, basically these are the change models. So VSI here refers to vegetation, soil and impervious surface. So as you can see, this is a kind of a Markov chain. So if a Markov chain, these would have some initial probabilities. However, if we add some external factors like GDP and liquidity to this Markov chain, the probability would change. The probability of transition would change. So this is what we are trying to model. So yeah, we can move to the next slide. So these are the basically the takeaways. So urban metabolism, as we know, it is a complex phenomena, and it is critical for like urban sustainability, for also urban activities. Like we see a lot of urban activities, so they have a like a significant impact of surroundings. Most of them, some of them are detrimental, some of them are like good, like they are generating jobs, they are generating capital, but a lot of environmental concerns are also there. So we have to model both. We can't be modeling one thing, and cannot be overlooking other things. So this is why urban metabolism is as important as is important for urban sustainability. So they enable quick and reasonably accurate estimation. As we can see, the carbon emission model that we saw on the previous slide. So that was a quick estimation. And so, yeah, so this, I think, how much time do I have? So how much time do I? So yeah, so I would like to wrap it up. So thanks everyone for like listening to this. Thank you.
Thank you, Mr. Shreyan, and thank you to TCS for sponsoring and making this event possible. And now up next we have GRS's Idea Awareness Talk by
Just download. Yeah, అక్కడ నుంచి అయినా ఓకే. Okay. How does just download it? బట్ ఇన్ దిగ్విజయ్స్ ఆ స్టూడెంట్ దాంట్లో ఓపెన్ అయ్యింది ఆయన ల్యాప్టాప్లోనే ఉంది. ఒకసారి మెయిల్ క్లోజ్ చేయండి. About a 5 minutes presentation about the GRSS idea. A talk by myself, Sai Kumar Tara, an IDEA member at GRSS. And this luncheon was sponsored by GRSS IDEA. Next slide, please. Okay, next. The full form of the idea is inspire, develop, empower, and advise. And we do have a lot of activities which was done under idea GRSS. Next. This is our idea team. Next. Okay. This slide is about to nominate someone who is very impact or GRSS who has done a lot of work regarding the topics which are related to GRSS. And next one, there are a majority awards. You can nominate someone who knows, who are working in the GRSS. The timelines are from September to December annually. The links are available at the bottom. Next. Okay, these are our DL talks. I hope the yesterday's talk, even in the inauguration, you have seen one DL, Annabella. And among this, all the DLs, I have seen two. One is James, another one, yesterday I have seen Annabella too. And you can approach, if you have a student branch in your SB, and if you have a GRSS chapter, you can have an online talks with the GRSS DLs also. Next. The vision mission, you can go through it. This is one of the events that we are celebrating this conference, Earth Sense 2025 at Yale University. Next, there are different activities that we are doing under GRSS. The activities are, next. The activities are like this. Women Mentoring Women is one program, conference activity that is Dr. Mausmi is looking after. There are so many grants, even there is one superb grant which I like is family grant. Even you can come with your family to the conferences. And Women in Africa. And even we do have a social media bands. You can just follow it and we update everything about GRSS in our website. Next. This is about Women Mentoring Women. The mission is to enlighten the women to mentor even in their tough times also. We have so many women leaders. Next. Next one is Professional Development Micro Grant. Hope the people who have here might have applied some micro grants also. Even you can for this, to apply for the Professional Development Micro Grant, you should be an active volunteer of GRSS, and you can apply for the conferences too, and a maximum amount of $500 will be given to the participant. Next. Okay, this is one of the feather of GRSS idea is about women in Africa. There is a lot of activities, and our team is motivating the women in the Africa. We are doing this activity from past 2 years. Next. And they have conducted a lot of webinar series too. This is one more grant which I like is family grant. You can get your family to the conferences too. And about you will get about $500 at a grant, and eligibility for this conferences like IGAS and INGAS, M2 GRAS conferences you can apply. Next. Okay, the interested people can just scan this one and you can become a member of the GRSS too. And thank you. Next. Okay. Become a mentor and mentee today. Hope the people will join this GRSS student chapter member, becoming a member at GRSS. Thank you, Dr. Mausami, for giving this opportunity. Catch you.
Thank you so much, Saintara sir, for sharing the thoughts and initiatives about GRSS idea. We'll have a lunch break now, and at 1:30 p.m. there are few technical sessions left out. We'll continue with that, and we'll be back for the innovation talk for in space industries at 1:30 p.m. Thank you.